All right, so now let's look at the function x squared plus 2x minus 15 and the function x minus 3. Well, f of 3, that's going to be 9 plus 6 minus 15 is 0. G of 3, 3 minus 3, also 0. So direct substitution doesn't, that limit is x goes to 3. So direct substitution doesn't work because, again, I get something that is indeterminate. If I did my direct substitution, top value goes to 0, bottom value goes to 0. This is also indeterminate. We don't know what 0 over 0 is. But we learned other ways to find this limit. So algebraically, that's supposed to be a 3. Algebraically, we know that x squared plus 2x minus 15 cancels. That's going to be x plus 15. I said cancels, I meant factors, over x minus 3. There's my canceling. So really, if I think about this quotient, the graph is going to look like a line with a hole at 3. But remember, a hole at 3 doesn't matter when I'm evaluating limits. So if this is my graph, then my limit from the left is the same as the limit from the right, and that's going to be the same as the limit as x goes to 3 of x plus 5, which is 8. So that's what this graph would look like, and that limit exists. So the values of f of x and g of x at 3, how do they compare? Well, they're equal. F of 3 equals g of 3. But which one's changing at a faster rate? Well, for sure, x squared, a quadratic graph, changes faster than linear. So f prime of 3 is greater than g prime of 3. Well, let's think about finding the limit as x goes to 3 of those things. So f prime of x is going to be 2x plus 2. G prime of 3 is going to be 1. So then when I substitute, which I can do now, I'm going to get 2 times 3 plus 2. 6 plus 2 is 8. And now I see that my 8 is the same value as I got for my limit. So when we have an indeterminate form from the original, looking at growth rates is another way for us to evaluate the limit. So this is the idea of L'Hopital's rule. So when I'm toolkitting L'Hopital's rule, so if my limit as x goes to some value, and that could be infinity or a number, of some function f of x over g of x, if that leads to an indeterminate form, so either I get plus minus infinity over plus minus infinity, or I get 0 over 0. And I have to show evaluating top and bottom separately. So you could use arrows, you could look at the limits individually, and then you say, therefore, is indeterminate. Then the limit of f of x over g of x can be evaluated using the derivative. This is L'Hopital's rule. So we have to say indeterminate, and then we show using the derivative. If we get indeterminate again, you can keep going. So you could use second derivative if the first derivative is indeterminate, but you would have to say a second time is also indeterminate. When we do our check your understandings, we're going to go through this again.